let's say a population has a mean mu equals 77 and a standard deviation of sigma equals 18. Find the mean and standard deviation of a sampling distribution of sample means with a size n equals 36. So one critical thing to notice here is that the shape of the original distribution is unknown. They didn't say whether it was normal data or rectangular or approximately normal or anything. They didn't mention it. Now, why is that important? Well, if you go back to the central limit theorem table up here, it says that if you know your original distribution shape to be normal, then you can assume that the shape of your x bar distribution will also be normal, no matter what the sample size. If you think that your original distribution is approximately normal, then you could assume that the distribution of your sample means will also be approximately normal. But what we have is a situation where we don't really know what the original distribution is like. It could be anything under the sun, even rectangular or bimodal. You just never know because they didn't say about it. So what we'll do is assume that it's not normal, you know. But check this out. They are taking a sample size of n equals 36. N is greater than or equal to 30 here. So with that in mind, we can use the central limit theorem which says that our mu of our x bar will simply equal the mu of the original distribution. So since the original distribution had a mean of 77, our sampling distribution will have a mean of 77 too. Now here's the tricky part, finding the sigma of the x bar. The original distribution has a standard deviation of 18. But our distribution is going to be narrower and taller. That's what happens when you take a sample size that's bigger than 1, is you actually shrink the distribution. So we have to use a formula for this. The formula is you just take the original standard deviation and divide by the square root of n. So this is going to be 18 over the square root of 36. That gives us a standard deviation for the sampling distribution of 3. It's much narrower of a curve than the original distribution. So whereas the original may have been super wide, that's the x. When we go to draw the x bar distribution, it will be thin and tall because it has a smaller standard deviation.